We're going to keep this going backwards theme going. It's kind of different, so I'm going to stick with it. So number 30 talks about the half-life, and I drew an arrow right at this one. As soon as you see half-life, you don't want to use this one. You want to use this one, okay? And we need to kind of discover what A is and what B is. A represents the initial value. B is kind of the rate of decay or the rate of increase. And in this case, it's the half-life. So we know that B is going to equal 1/2. Now we need to be careful. It says there's 4.5 grams initially, so that's our A. So A is 4.5. Now if we go to put stuff in here, it's in terms of T. So I'm going to take these X's out and make it, and I don't want to confuse you, but F of T equals the initial amount times 1/2. But then it says it takes 8 days for it to be cut in half. So in order for this number to be cut in half, we need to make sure we're accurate up here. It's T over 8. Because on the 8th day, then 8 over 8 is 1. 1/2 to the 1 power would cut this in half. So that's how you should think of it. But it says when will there be, and this less than is just going to throw you. Don't worry about that too much because we're going to concentrate on equals, and we'll talk about that later. So it says, when will there be 1 gram remaining? If you just eliminate that, your brain might function a little bit better because that's what we're going to put right here. So 1 equals 4.5 to the 0.5 to the T over 8 power. Now this is a little bit of a stinker of a problem. But you definitely need a calculator here, and we're going to do some basic math here. So we see that we can divide by 4.5, gone. Divide by 4.5. Now I'm going to clean this up. 1 divided by 4.5 is 0.222. Let me make sure I didn't screw that up. 1 divided by 4.5. All right. So I get 0.222 equals 0.5 to the T over 8 power. Now we didn't spend much time talking about these. So this might be something you forget, but I talked about common basis happy places all down here, and previously that is not going to happen here. So this is where I made a joke about it, and I said this is a very chilly math problem. So you need to slap a log on this side to warm it up, and you need to slap a log on this side to warm it up. Now why would you do that? Well, the variable that we're trying to find is up in the numerator, up in the exponent. So we're going to take advantage of law of 3 and bring that in front. So I know I'm running out of space here, but I'm going to rewrite this. I'm going to figure out what this is first by just going log of 0.222, and that's negative 0.65. So negative 0.65 equals, now I'm going to bring this in front, T over 8 times, I got to figure out what log of 0.5 is. So log 0.5, negative 0.301. So I'm just going to call that negative 0.3. And I'm just going to choose to divide this whole side by negative 0.3. So that disappears. Negative 0.3. These two negatives are going to cancel. So I'm just going to go 0.65 divided by 0.3. And so I get I'm just going to call that 2.17. So 2.17 equals what? T over 8. I'm going to multiply by 8, so these cancel. Multiply that by 8. So I'm going to go times 8. And that's 17. So T equals 17.33. Now we need to talk about this. The answer says 17. So on the 17 point, I think we'll just consider it rounded. Let me double check that. Okay, they didn't say 7, they said after 17 days, which you can tell, 17.33 days. So the answer is after 17 days. Okay, so let's go to number 29. Number 29 is a lot easier, I think. So it says in 1988, the population of certain U.S. city was 2.3 million and is increasing at a rate of 6.3%. So we're going to use this formula this time. So starts out by saying the initial population was 2,300,000. Then we're going to go 1, and it says increasing, so we know it's plus. 6.3% would be 0.063 as a decimal each year. So that's just T. At that rate, in what year did the population hit 4 million? See, that's the desired amount. That's what we're going to put right here. This is the initial amount. This is the desired amount. So this would be 4 million. And what I'm going to do to clean this up is I'm going to take, see this has 5 zeros. I'm going to take 5 zeros off there. I'm going to take 5 zeros off there. So I get 40 equals 23. In other words, I divide by 100,000, if you want to look at it that way. 1.063 to the T power. I'm going to divide by 23, so that's gone. Divide by 23. I'm going to clean that up real quick. So 40 divided by 23, 1.74 I'll call it. So I get 1.74 equals 1.063 to the T power. Again, there's no way I'm going to find common basis here. So that's where we're going to use the log. So we're going to slap a log on this side. We're going to slap a log on this side. That will turn this into an actual number. So I'm going to go log of 1.74 is 0.24. The point equals, and again, I'm going to do two things. I'm going to bring that in the front of the log using law 3 of logarithms that we learned in this section or in a section previous. But I also need to find the log of 1.063, 0.026. So I get T times 0.026. So I'm going to divide by 0.026, gone, divide by 0.026, and here it comes, 0.24 divided by 0.026. I get 9.23. 9.23 years is the amount of time, but then it says in what year. So the answer says sometime in 1997. So if you add this 9 to this, you'd have 1997 and then a little bit more. So that's why they get away with saying sometime in 1997. All right, let's go to number 28. So the cost of gas per gallon has been increasing at a rate of 11%. So here we go. It's going to be another one of these. If the cost is now $2.20, what will the cost be in 10 years? So the initial cost is $2.20. It is increasing at a rate of 11%. Well, that is 1 plus 0.11 per year. So that's T. And it says if the cost is now $2.20, what will be the cost? In other words, they're asking us to find P of T. That will be the cost of gas after 10 years, which I can put right here. So that's actually 2.20 times 1.11 to the 10th power. Give me a second. All right, just to make sure I have my calculator ready, we got to go 1.11, raise that to the 10th power, and then we're going to multiply that by 2.2. And at that rate, gas would be $6.24 or 25 cents. Pretty expensive. All right, so let's keep going with this one. Number 27, determine the exponential function f of x equals ab to the x. Now, I know a lot of you, when you see this, you might go, oh, this is x1, y1, this is x2, y2. I understand that instinct, but that is not what they're asking you to do. They're not asking you to find the equation of a line. They're asking you to find the equation that is categorized as an exponential equation. So this is where we go, wait a minute, I remember these, but it has been a while. My x is 0 and my y is 2. My x is 1 and my y is 5. And remember, the trick is to think, okay, if x is 0 and I put it in here, what would b to the 0 power be? B to the 0 power is 1. That tells us that this is our a. If x is 0, it would eliminate this. And f of x, remember, represents y. So y would equal 2 if x equals 0. That's what it's telling you. So let a be 2. So we're almost done. So that's 2. Now we got to find b and raise that to the x power. Now b is the multiple from the y to the next y. Whatever you have to multiply this by to get this. So if this was a 6 instead of a 5, we'd go, it's 3. But that's a 5. So maybe we'd go 2 times some number gives me 5. So I'm going to divide by 2, and I go, hey, x is 5/2. And that is the multiple taking me from the first y to the second y. And that's how you do these weird problems. Now we're going to get into some more exponential stuff. Well, first thing you have to know is that these two negatives do not cancel each other. This negative right here, and again, I'm only concentrating on the top, means flip it or put it where it ain't. So I'm going to put all that stuff in the bottom. And now that I've obeyed that negative, the negative disappears. And I'm going to go ahead and finish this. Negative 2 cubed is negative 8. And a power to power, I multiply. Now I need to concentrate on this. Now I need you to notice there's an invisible 1 there. That means that 3 is not going anywhere. But this is x to the negative 4, so that's going to go up. And it's going to turn into x to the 4th. Now I just got to clean this up. Well, negative 8 times 3 is negative 24. Where are there more x's? Down the bottom by 5. So I got to put a 1 on the top, and that's number 26. One step at a time. All right, so this 25 is saying solve it graphically. The first thing our thought should be is, hey, this is a y equals x squared kind, which means it's going to be like this. If a is positive, it's going to be like this. If a is negative. Well, as you can see, we have a negative right in front of the x squared, so that means it's going to be a sad face. Now, there is no shift in the x direction, but I do need to go down 3. So that is going to be from here down here. It's a sad face. And this is where we said, okay, y is less than. Our instinct is to shade underneath. And it's less than or equal to, so this is a thick, full line. I accidentally put it in there by habit. But if this wasn't equals, that'd have to be a dotted line, and you have to look for that stuff. Now, what did I say when I taught this? I said check a point and see if your shaded area probably makes sense. We can plug in 0, 0 very easily. So 0, that's the y right here, is less than or equal to 0 minus 3. Is that true or false? Well, that's false. Well, it's good it's false because it's not in my shaded area. That makes me think I did it correctly. Very similar, but this time I've got a y equals x squared kind, and a is positive. I don't have a negative in front here. I have a positive 1. And I know that the vertex is going to go down 5. 1, 2, 3, 4, 5. But this is going to be a happy face. Not too worried about your accuracy of your parabolas. Just get the general idea. Now, y is less than or equal to this stuff is kind of telling me underneath. And there would be my answer. Again, I forgot to mention or think about that this needs to be thick because it's less than or equal to. If it was just less than, it would be dotted. Now I'm going to test this point, 0, 0. 0 is less than or equal to 0 minus 5. Again, it's false, which is good. That means my answer is correct.